Hello, welcome back. Today would still be looking at the Ford focusing algorithm, but we're going to start by looking at the main max cut theorem. I'm just going to talk about the theorem, then we move back to the last example we took from the other video and figure out where a suitable cut, a suitable min max cut for that example. So, what to note about the min max cut? So the min cut is a cut that has the maximum value. We always want our max flow to be equals the min cut, okay? Our max flow will always be equal to the min cut. So let's just explain this in plain English. If you, on the screen, you're going to see, let's call these two different trees from a graph, right? So these two trees, let's call it S and V minus S, they contain vertices, of which when you connect the both the both trees, you have a graph. So using this to explain the min max cut, we want to say that for the outward flow, and by outward flow, I mean the flow going from source to the sink, going from S to T. For the outward flow in the original graph, we have a maximum flow when we have used up all the capacities from the source. So we have a maximum flow if we've used up all the capacities from the source. If we still have some capacity on, let's say, the UV or AB edges, that means if we have a flow that can still go from the source down all the way to the sink, then we don't have a max flow yet, right? And the next condition we want to check. So let's explain this like this. First of all, we want to check if we have max flow. Check for max flow. We want to check if we have max flow. Then the second one, we want to check for reachability. We want to check for reachability. Okay. So if T is still reachable from S, if your sink is still reachable from your source, then we can't have a min cut yet. So let's say V. If V is reachable from S through U, right? Then we cannot have a min cut yet. So you want to check, first of all, before you draw your min max cut, you want to check for max flow, and it's not or, and you want to check for reachability. Can any of the edges in your sink or pointing to the sink still be reached all the way from source? That's what you want to check. If you can, we can't have a min cut yet. So we can only have a min cut if all capacity, first of all, if we have a max flow, that means all capacities has been exhausted, and our sink, we can find, an edge that cannot be reached, or we can find edges on the sink that cannot be reached from the source. So let's grab our first example from, and like I said at the beginning of this video, always our max flow will always be equals less than or equals our min cut. Let's look at the example from the last video. So we look at this example, we want to draw a min max cut, and let's see. So we can draw that cut here, because let's say we can draw that cut here. Yeah. So let's verify. Of course, from the last video, we found that we reached our maximum flow, right? And let's check for reachability. That's what we want to check now. So C, you have A, B, C. Okay, let's draw this way. Yeah. So you have T cannot be reached from C. C can be reached. You have S, A, B, C, right? So you have, this is a cut, S, A, B, C. But we can't reach T. And we have D, right? D can be reached from T, but S can't be reached from D. And the reason is because if you look at the direction of the arrow, if we go S, A, B, you can't get to D because the arrow from D is pointing to B, if that makes sense. D would have been reachable from B if the arrow from D to B was the other way around. If the arrow was this way, then we could have said we can reach D from B, right? But it's the other way around. We can't reach D from B. And if we took the other route, let's say S, A, B, C, we can still reach D. So this would be a good cut. S, A, B, C, then DT. So this is a good example of a min-max cut. So we're going to cut this video here. In our next video, we'll solve another example, our second example in network flow using the forward focusing algorithm. If you liked this video, please do subscribe, like, share with your friends, and I'll see you in the next one.